Hi, this is Justin, G0KSC of the G0KSC website and Antennas. So set myself a challenge today, and that's to build a Yagi within EZNEC using just the information that we've got from a website or written down, and do that in under 10 minutes. So we're going to be fairly swift with this and run through it in order to give you a good indication of what to do. First off, I've got a treat for you guys, some templates for you to use. What you need to do is to go to g0ksc.co.uk /YouTube in capitals /4.zip or ZIP for our American friends. When you press return, you'll have a download option at the bottom where you can, at the bottom of the browser here, where you can see open or save as. Just for those that haven't seen any of the tutorials before, the mouse is highlighted with the yellow circle, and when I right click on my left-handed mouse you get that green target sign up, so you know what I'm doing with the mouse. So once you've got that, you can open that up and select any one of those files that you wish to use. I've used this one, this 4-element on a 3.5 meter boom, and now what I'm going to go is to the 50 megahertz LFA section here, and then let's have a look and see what we should pick out of here. So let's take the 4.4 meter long 5-element here, and then what we're going to do is we're going to translate this. These are antennas that other people have built previously using these dimensions, but we're going to take a look at putting these into EZNEC ourselves. So we've got all of the boom positions here of where we need to be, and the half-element lengths which we need to put that into EZNEC. So first off, this is the information that we'd see when we open up EZNEC. The first thing I want to do is change the name of that, so 5L Yagi by me. So the description is what I want it to be. I'll then do it as a sanity check. I'm going to just save this on the desktop. I'm going to call this 5L LFA. So that's saved, and now we're ready to go. So I open the wires window, and just for the purpose of showing you where everything is again, we'll open up the view, so of view antenna, so we can see the layout of the antenna, so we can see the changes as we go along and what we're doing here. We don't need the main screen, so I'll move that away. So we've got the wires window. I'm going to move that just above here, so we've got the details that we can see below. So we can see the reflector position is X, and this is the X-axis, so these are the positions along this X-axis. The Y-axis here are the elements either side of X, and you can see on this side it's minus 1.488 meters, and this side it's plus 1.488 meters. So minus this side and plus this side. So the total length of that element is the sum of those two. So that's the first bit out of the way. The second bit we need to do is to change the positions of the elements. But what I will do is, and what you will notice here, is unlike on the previous videos where we've been looking at the OWA or optimized wideband array, which is used in a single dipole fed Yagi like this. We have a feed point indicated by the red circle, as we discussed before, and we see the segmentation dots in green, but these blue dots are relatively new. We haven't seen these before, and these are where wires are joined. And with the LFA, it's a loop fed array. It's got a full-sized or a full wave loop that's laid flat on the boom between the reflector and director elements. So that's where it's at the moment. So let's go in and we're going to change the positions, but because we have these joins, if we click the preserve connections button here, any changes that we make will remain, and the best way for me to do this or to demonstrate this is to show you. So I'm going to change that to 314, and then we change this to 314, and when we notice these are still on 346 here, now they've jumped to 314 as well. The next one is 866, so that's a smaller position, so 866, and I'm going to change this one to 866, and you can see the others have changed as well. So now that the boom position for that one has changed. So now we're going to go onto the first director, and you can see that we're highlighting the first director here, and that's gone to number 6 in red, so it shows you where we are on the field there. So that's going to be what's that, 1.381, and then 1.381 here. So you can see that's a big difference, big change in where it's at. Next one is 2675, so 2.675 and 2.675. Now deliberately so, I didn't add the last element in, so you've got to do that one yourself from scratch, but you can pretty much copy it up from the ones that we've got below here, or above, sorry. So 4.354, that's the element position. The next one that we've got here is going to be the half element length. So as above, minus 1.298, and that's this figure here, 1.298. Okay, 4, and then 1.298. That gives us that. The elements are the same. We'll leave the segmentation for the same at the moment. So now when we do that, it's now jumped, and we've got the extra element on there. So all we need to do now is we've got to go back to the other elements and change those to the sizes. These are the half element lengths, so that one's got to be down to 3, and this is a generalization here, but and it's not a golden rule as such, but generally the smaller the antenna, the bigger the reflector, and the smaller the last director. As you get longer in length, the rear element tends to be not quite as large, and the last element not quite as small. And once you get into multiple wavelengths, then it does change. But for up to sort of 9 elements or so, that's pretty much where it's at. So that you can see the loop now is a little bit wider as well. So we're going to change this to 44. But remember, we won't have to change some of these on the loops, because that's going to change itself, because we've asked it to preserve the connections. So that's now 44, and then the next one is going to be 402 and 402, and then we've got 357 and now 357. So that's all of where we are. We've got everything in there. I think that should be good to go. So let's take the browser down for a moment. We'll get the main screen back up, and let's just see what that looks like. So now we can see we've got a really nice looking plot, really nice looking antenna. And how does that look when we do the run and see how the SWR looks? Well, that looks pretty good to me. Even if we open that up now from the base to 50.6 and do a run again, we can now see that it's got a double dip, nice and low around 50.2, nice and low around 50.55, pretty flat in between, and then the azimuth plot looking from above the antenna, really nice and tight. And if I do the elevation plot again and have a look, that's pretty damn suppressed here as well, so it'll be good under in a noisy location, this one. So all in all, that looks pretty good. That's the first Yagi built in software. So we're going to save that now, and we're all good and ready to go. So pretty much that's all you need to do, just to take into consideration that in some of those, when you some of the antennas that you'll find where it's got the element lengths, it will be the whole element length, and you need to halve that, minus part of it in the Y position and plus part in the other Y position, and then you're good to go. Thanks for watching, and please subscribe.